welcome to my talk about blockchain, NFT, and smart contracts for Java developers. I'm Hendrik Ebbers. I live in Dortmund, which is quite nearby, and I mostly, I do a lot of Java stuff. So I'm a Java champion. I'm heavily involved in the Eclipse Foundation today, so I'm part of the Adoptium working group, of the Jakarta EE working group, and I'm a member of the Eclipse board. And next to this, I have a company which is Open Elements, and that company concentrates on open source and Java. And one big open source project where I'm currently involved in is the Hedera Hashgraph, which is like the biggest public ledger that is created in Java. And while doing that, I learned a lot about all those buzzwords like NFTs, blockchain, cryptos, and so on. And today I would like to give an introduction to that, but do not hype it, but really look behind the curtain and see what technologies are involved there, how it is really working from a technology point of view, and so on. Oh yeah, and next to all this technical stuff, I love Star Wars, dogs, board games, and open source. So, what do we will see today? I will talk about smart contracts today, about tokens and NFTs, and maybe what the difference from a technical point of view between those is, and what a public ledger or a distributed ledger is anyway. Actually, I will not talk about those topics today. So if you are here because you want to learn how to trade Bitcoins, sorry, you're wrong. And I have absolutely no idea how you can get rich by buying or selling such ape pictures as NFTs or something like that. So who in the room already owns any like cryptocurrency? Oh, quite a lot of people. Okay, interesting. But next to this, I would say like half of the people here in the room do not own a cryptocurrency, and maybe several of you never got in touch with cryptocurrency. That's why I would like to start with a little bit of history regarding cryptocurrency, and especially about Bitcoin. So I will start with a question, which is, who is Satoshi Nakamoto? So who knows who Satoshi Nakamoto is? Okay, so everyone who now holds a hand, you are great, because nobody knows it, right? The press don't know who it is. You don't know? You know who it is? Can you introduce me to him? Yeah, but you don't know who the person is, right? Because that is something interesting. You're totally right. Satoshi Nakamoto is the inventor of blockchain. And he created he or she, or I don't know, created in 2008 a white paper. This one, you can get it at bitcoin.org, for example, that introduced like the technology behind blockchain and how blockchain is working. And it describes more or less, not blockchain, Bitcoin, sorry about that. And it describes Bitcoin more or less as technically as a decentralized blockchain without any trusted parties or leaders. And next to this, some goals of Bitcoin were defined, like, for example, that it should be an everyday currency, which means like the euros you have in your pocket. With Bitcoin, you can just buy anything you want, like you do it with euros today. It should have less exchange cost than, for example, changing euros to dollars. And instead of having a trust against banks, where maybe you have your bank account and where most of your money is placed, there's a cryptographic proof that does all the transaction work between two partners, like if I send money to another partner or if I buy something for my money. So while some of those points are in a quite good state, especially as I would say the first one until now is not happened, right? Because I cannot go to a supermarket and pay with bitcoins for my apples or something like that. So regarding the idea of bitcoins, we are still somewhere in, kind of, I don't know, maybe gold rush or something like that, and somewhere in the hype. So going back to Satoshi Nakamoto. So as said, he invented Bitcoin, and then he implemented the, let's call it like the Bitcoin client, or the software that you execute on your PC to be part of the distributed Bitcoin network, and that was created in open source, and Satoshi Nakamoto committed to it, and you can really just find it under github.com/bitcoin/bitcoin. There you can go, could create an issue, could create a pull request if you want, can build it on your own, whatever you want. Then something strange happened, because 1 year later, in 2010, Satoshi Nakamoto became inactive. So he stopped doing commits, he stopped doing commented on stuff like that. And even today, nobody knows who this Satoshi Nakamoto is. Because he created this paper, he worked on GitHub, and I always say he, right? But it could be she, or it could be a full group. I mean, nobody really knows. Satoshi Nakamoto is only a name in the internet that is used for the paper, that is used for example, the GitHub username and things like that. But in reality, nobody really knows who it is. And funnily, if you Google that or watch a documentation or something like that, really within the last years, several people claimed to be Nakamoto. But normally the press or other institutions proved that those people are not Nakamoto. So why do people want to be Nakamoto? Yeah, because he's really rich, right? So we know that he has a Bitcoin wallet, a Bitcoin account, because we know the address from the account that Nakamoto used all the time when he was active. And on this account, there are somehow between 750,000 and 1 million Bitcoins. So any idea how much this is in euros? A lot, right? So I have not calculated that one, but so I've did it like, I've created that slide at the end of 2022, though it was like 1 Bitcoin is $19,000. So you can assume what 1 million Bitcoins is like. For what I really got the numbers is for all the Bitcoins that got lost over time. Because some analysts reported that something between 2 and 4 million of Bitcoins already got lost because someone has stored the cryptographic information on a hard disk and thrown that hard disk into trash, and people started to, search in the trash for the hard disk and things like that. And converting that one to dollar is like, what is it? $59,133,000,000 of Bitcoin already got lost. And that was 2017, right? I assume this number hasn't become lower until today. So that's so far for Bitcoin. But I mean, since that was such a hype topic, the IT haven't stopped with Bitcoin, and shortly after Bitcoin started and was a success, a second generation has become quite popular, and there especially Ethereum as a distributed ledger. Who never heard about Ethereum? Okay, you heard about it, yeah. So most people heard about it. Okay, great. So again, Ethereum is a distributed ledger, and that one was created in 2013 invented in 2013 by Vitalik Buterin, who created again a white paper for the Ethereum network, and then 2 years later, the network started. And Ethereum does a lot of things different to Bitcoin, because Bitcoin really concentrates on the coin, right? In the Bitcoin network, you can more or less do nothing than create transactions regarding the Bitcoin. So you can buy stuff or share Bitcoin, so you can trade the coin. But Ethereum has something quite new, which is the EVM, which is the Ethereum virtual machine. And that is like the Java virtual machine, a virtual machine that you can use to execute code. So within this distributed ledger of Ethereum, we have a virtual machine where you can execute code in transactions regarding the network, which means like when I execute code on this EVM, once the code is executed, the state in all the clients of Ethereum around the world are the same. And that's quite freaky if you think about it, right? You execute code somewhere, and after some time, all the 10,000 clients around the world, wherever they are, have like the same state based on whatever code you have executed in this EVM. And next to creating coins, so the Ethereum network has a coin too, which is called Ether. It's the ETH coin. The Ethereum network was more used to create Web3 applications, because with this EVM, you were able to really execute code on the network and code that you have created. And I have just one example what you can do with it. We will see other examples later. But the example that I will show today is a game which is coming from the company keine. And the game is called Axis and something. Axis Infinity. Who ever heard about Axis Infinity? Well, 3, 4 people, okay. So who know Pokemon? More people. So everybody who knows Pokemon, this is like Pokemon on Ethereum, right? Because what you can do in this game is you get this so-called axis. It's kind of animal. This is just an example. And each axis that only exists digital is unique. So maybe you have horns like that one, you have a tail like that one, or whatever, you have different eyes or different ears or different mouths. And the uniqueness of that axis is stored by its DNA really in the blockchain of Ethereum, unmodifiable. And then, like in Pokemon, you can, for example, like fight with your axis against axis from other people, right? And see who has the greatest axis. Or you can like pair 2 axes, like my axis and an axis from another one, and create a little axis child. And that axis child is then based on the DNA from their parents, and again stored in the blockchain. And as more childs an axis has, as worse the DNA of the child becomes, and so on and so on. And to show that this is really a thing, I have just this is a screenshot I did like some time ago, where you can see from a marketplace, so some different of these axis animals, and for how much money those are sold, right? So this is roughly about $200 to $300 that people sell to get a good axis. Like people sell on eBay for Pokemon cards, for example, right? It's more or less really the same, but on a blockchain based on Ethereum. And that's really a big thing. I mean, here you see like partners who invest in that, and why I have no idea about some of the companies. I mean, we have Ubisoft here, which is one of the biggest game companies in the world. We have Samsung here, so really big companies invest in applications in scenarios like this one. So coming back to Ethereum, today we have a foundation, the Ethereum Foundation, that is located in Switzerland. And already 5 months after the Ethereum network had started, it was already worth $500 million US. Today it's about like 150 billion US dollar. Bitcoin is still way more, right? Because Bitcoin is still somehow hyped. But with Ethereum, I mean, I don't care if someone gives me 360 billion or 150 billion, right? So both is unbelievably high. And with Ethereum, you can do way more. On the other side, you can do way worse. And that already happened with the Ethereum network. So let's have a look at 2 examples how Ethereum became hacked in really a horrible point of view. So first was the DAO hack. Who ever heard about that? Okay, some people. So in 2016, the Decentralized Autonomous Organization, DAO, has been created on top of Ethereum. And the idea was that with this organization, you do not have like a CTO or a CFO who is aware of all the finances, but I as a person can buy tokens, and based on the tokens I have, I can do votings, because code is executed in Ethereum, and when I do a vote based on the, let's say just like on the tokens that I have in this DAO, my vote is counted in a special point of view, and we do not need any managers or any decision makers, because we are all the decision makers, and my code is from a percentage view worse based on the tokens, the amount of tokens that I have. Quite a good idea, and with just a short time, the DAO already raised 150 million US dollars based on 11,000 people who became part of the DAO. Sadly, in one of the smart contracts that are executed on the Ethereum blockchain was a bug. And some hackers found this bug and stolen 3 million Ether, which is like, at this point was around $60 million from that organization. And that was horrible, right? This is like half of the money that this organization had was stolen by a bug. And this was the worst, really big and horrible Ethereum or problem that Ethereum had. And to fix that, Ethereum did a hard fork. So Ethereum and the blockchain and the data inside of Ethereum was really forked to restore the funds of the people where the money was stolen from, or let's say like the token was stolen from. And yeah, I mean, that's a problem, right? So you have a blockchain, a decentralized system where you say, okay, this is our system of trust, and now you do a fork because there's something you don't like. I mean, I can understand that they don't like it, right? But that's really a problem. And some people do not agree on that decision, and that's why starting from that, we have 2 Ethereums, Ethereum and Ethereum Classic. Ethereum is the new one, Ethereum Classic is the old one. So that's the hack one. I have another hack. You remember those? The little X's. So that became one of the biggest hacks in IT ever. And that happened last year. So in March 22, 620 million US dollars has been stolen by a small group of hackers from this Sky Mavis company who's creating the game. And the awesome thing is that Sky Mavis created a public post-mortem for that one, so you can read about what happened there. And when you read that, it's unbelievable. So what happened here, the interesting thing is that the hack is not really technical, because what the hackers did is they created a company, a fake company, in the same town where Sky Mavis is located, a company that creates super awesome games on top of Ethereum. And they started to search for employees, and they paid way more than Sky Mavis paid. And they did advertisement on that on LinkedIn. And so a lot of Sky Mavis employees contacted them, and they did really they did really interviews with that people. So they did interviews with the people from Sky Mavis. Some of them had like 3 interviews in a row. and then they sent them contracts. And Unhappily, there was one person from Sky Mavis that opened the contract on the company PC. And that was the way how the hackers became got access to the Sky Mavis network. Right? That is unbelievable. But you can read about that online. Okay, that's about hack. I think another very important topic when talking about distributed ledgers today is the sustainability. I have a graph that I found online. This is the electricity consumption of Belgium. Right here you can see over the years how much electricity Belgium is using. Who has an idea how much electricity Ethereum is using or used in 2022 or in 2020? Anybody an idea? Is it like the half? Is it here in the bottom? Yeah. Roughly about. Yeah. That's Ethereum, but Bitcoin is worse. So here we see a lot of countries and how much energy those countries consume each year. And we see one thing that is not a country, right? Which is like between Poland and Norway. So Belgium is here in the bottom right. So Belgium is perfect when talking about electricity consumption. Germany is not that good, but not as worse as China and the States, for example. Bitcoin is kind of in the middle, right? So it feels a little bit like a country when talking about that. And so I do not want to blame those things, right? But this just feels wrong. And what Ethereum did is they changed a lot. And in August last year, Ethereum switched their internal technology, how they create the consensus over the network from a proof of work to a proof of stake approach. And that helped to lower the electricity consumption a lot and resulted in much better performance. So before that merge, Ethereum used like 22 billion terawatt by hour and created 10 billion tons of CO2 emission. And after the merge, it's, what is it, like 1%? Something like that, less than 1%. I found a nice picture on the Ethereum webpage, it's like that. So on the left, you see Ethereum before the merge, and on the right, you see Ethereum after the merge. So it's like having the Eiffel Tower and then a Lego miniature. Bitcoin, yeah, as said, that's not so good. That's really a problem. And while Ethereum is getting better, Bitcoin is getting worse, right? Because we have more clients, it is harder to create new coins, and so on and so on and so on. So for the Bitcoin network, it really don't get better. So to set those numbers in a relation, I really tried hard to find some numbers like, okay, how much electricity consumption has YouTube? How much electricity consumption has Netflix? How much electricity consumption has all data centers in the world? When talking about that against Bitcoin, any idea? So who needs more, YouTube or Bitcoin? Some say YouTube, some say Bitcoin. Netflix or Bitcoin? Netflix, okay. All data centers in the world or Bitcoin? Okay, that is correct, but all the others are wrong. So here you see like how much terawatt all the different things use, and all data centers in the world, we currently have like 200 terawatt per hour. And the good thing is that this is constant, more or less constant since 2015, because the technology is getting more sustainable and more sustainable. And Bitcoin is currently on 131 and is growing. And Bitcoin today needs more energy than the whole gold rush market. So like gold mining in total needs, which is a kind of problem. So we talked about Bitcoin, we talked about Ethereum. I would like to introduce the next generation. Even today, it's not like it was for Bitcoin, like it was for Ethereum, not only one product, but as I only talked for one product for like the first and second generation, I will talk about one product for the third generation, which is the Hedera network or the Hedera Hashgraph. And the big difference between Ethereum and Hedera is that you, as just a person, normally do not download the Hedera client and run it on your machine and be part of the network. Instead of that, there's a foundation, which is called the Hedera Foundation. And that foundation had a lot of members. And you see some quite famous companies like Boeing or Google, IBM, Dell, Deutsche Telekom, LG, and so on. And all those members run nodes of the Hedera network. And all those nodes are placed completely around the world. So there are some in Africa, some in Australia, we have Singapore, USA, Europe, Japan, South Korea, Kuwait, Brazil. So they are really distributed around the world. And I mean, by doing so, you can think about, I'm losing trust, right? Because when I do something on Ethereum, where we have 10,000 clients, more than 5,000 of those random people need to unite to do something bad against me. Here, IBM and Google and Boeing and Deutsche Telekom and Dell and maybe Ubisoft and maybe the Standardsbank need to come together to the table of evil companies and, you know, do something horrible against me to get a problem there. So from my point of view, it's not really a problem. But there's a big benefit, or there are two big benefits. One is a benefit in sustainability. Because doing it like that, you have way less energy that is needed for such a network. And the energy that is needed can easily be calculated, and the foundation for all the machines that are not already running on regenerative energy, they buy carbon offset certificates. So you have in the US, you have this carbon negative noun, right? That you say, like, even the carbon that we are using, we buy certificates to be less than that. And on the other hand, you have a much better speed when it goes to transaction, and both end in less cost when doing a transaction. So you can see currently at the Hedera network, there are about 40 million transactions per day. At Ethereum, it's about 1 million per day. There's a website which is just the Hedera txns.com, where you can see like the live transactions. So when I did that screenshot, it was in March. There are like 1,900 transactions per second. And we had 5 million, so it was over 5 million in March. Then I did that presentation in May at JavaLand. There we already had over 8 billion transactions. So it really started to grow. And I did it at the beginning of this week again, and there were over 11 million transactions, and today we already have over 12 million transactions based on this technology and the foundation. And that really makes it possible to have, and this is not coming from Hedera, this is coming from the UCL Center for Blockchain Technologies that tested it, so you can really like 3 times more transactions per second than the Ethereum network. But the good thing is that it's more or less compatible to the Ethereum network. And let me just switch to some other slides. And when using Hedera, you can use all the smart contracts that you can use on Ethereum in Hedera, because in Hedera, the EVM, the Ethereum virtual machine, is used too. There's an open source implementation of the EVM, and that one is used in Hedera. Hedera is completely open source. That's why I can tell about it, and that's why I can work on it. And so that one is 100% compatible to what you can do in Ethereum. And we will have a look at, for people who never seen a smart contract, how that looks in a minute. The good thing is that next to the mainnet, there are two other networks at Hedera, which is a testnet, where you can execute smart contracts and test your applications for free. That will be resetted from time to time. And there's a preview net that you can use to test the next version of the mainnet, because that is already always one version before the version. Or so this has the software version that will move to the mainnet with the next version update. And some examples of software that is using the Hedera Hashgraph. So every denizen, mostly nobody knows about that, but that's a huge logistic company, and they, for example, do the whole logistics for Essex, for the sportswear Essex, like the shoes, and for a lot of other companies. And they start to work on the Hedera Hashgraph to store product information in the Hashgraph. And you can think about a lot of interesting information that you can store in a graph where the information cannot be changed or deleted. So let's assume you have your own label, you do t-shirts, and you store where this t-shirt is created. And then there's one company, I don't know, in Bangladesh that is burned down. And then you can easily say, hey, look, we created in this and those companies, so we have nothing to do with it. Or on the other side, if everybody would use that, you could really check which company is using, which textile brand is using a company that has such horrible work conditions, for example. Another customer is ServiceNow, which is a quite huge help desk company in the US. And they use it to, like, when they create a ticket with SLAs, where it's important when is the ticket created, when is the first answer coming, and so on, right? Because you have that defined in contracts, you can store the timestamps or the hashes of the timestamps in Hedera, and by doing so, you can always prove against your customers that you handled within the defined time slots. Another company is Resource, that is coming, or the manager of Resource is one of the ex-managers from the PlayStation studios. And they did The Last of Us, Uncharted, Days Gone by, if somebody knows about PlayStation games, and those are currently working on a game that uses Hedera to store, like, they really use NFT technology, for example, to store assets that you can use in games on the Hedera Hashgraph. Okay, that's enough about, like, specific ledgers like Ethereum or Hedera. Just to give you an overview, there are several ones, and currently we're in a kind of third generation from my point of view. We now heard a lot about smart contracts, right? So let's have a look what a smart contract is. Let's assume you do gambling, okay? And we have Alice and Bob, and they gamble. And Alice and Bob don't trust each other, right? So you need a person that both trust, which is in this case Carol. So both of them give like $100 to Carol. Maybe they gamble on horse riding or whatever. I don't care. And once somebody of the two wins, Carol pays like $180 to that person. And the $20 that are missing, that's the money that Carol earned because she's a man in the middle. She has to do something, right? Both needs to trust her. That is what you get for $20. When using smart contracts and a blockchain, you could have like a smart contract in a distributed ledger that maybe has a function's deposit with a given amount and request payout. And now Alice could call the deposit function, and Bob could call the deposit function, and then after the horse riding, Alice gets like $199.99. And the 1 cent, that is for executing the functions on the blockchain, because that is not for free, but that is way cheaper than doing it with a man in the middle, for example. Some other use cases are decentralized finance. We talked about this decentralized autonomous organization, peer-to-peer markets. There's a lot of things popping up. I read about people that buy houses together and then share them based on NFTs and things like that. And all that is done by smart contracts that are running on the Ethereum virtual machine. And that one you can really think about the Java virtual machine. I mean, you cannot run Java on it, but you can write your smart contracts in one of the supported languages. There are some of them, but I assume everybody does it in Solidity, but there are some others that you could use. And those are really then compiled to bytecode, like in Java, and then executed in the EVM, in the Ethereum virtual machine. And like in the Java virtual machine, you then have opcodes like stop, and add, a shift, or whatever you want to happen, and this is how the bytecode is executed internally. And one interesting thing here is that column, right, the gas column. And the gas column defines how expensive the operations are. So when you execute a smart contract, based on the opcodes that are executed in the JVM, it's really based on that one calculated how expensive an execution of that code function, whatever you define, costs. And whenever you execute a smart contract, you need to define what the maximum that you would like to pay. Because, so let's assume you want to do something in the Amazon cloud, right? So you set up a machine in the Amazon cloud, and then you call, for example, a serverless call. And you did something wrong, and you have an infinity loop in that serverless call. That's not a problem, right? You can stop the machine, easy. But here, you would need to stop the whole network. And that is not possible, and nobody wants that, right? And that's why you define, when executing code, how much you would like to pay in total for it. And then the code is running, and if it's more than that, it will really end in an exception or an error or however you want to call it. You don't need to do wild guessing. There are calculators, how you can calculate how much gas things might cost, will cost, or you can just say, I don't know. I mean, the maximum is like 10 cents per execution if you have normal executions, because normally you are way under 1 cent for an execution, right? So we do not talk about paying a lot of money for executions. It's really less than a cent that you pay for it. And as said, there are different language. We want to have a look at one, which is Solidity. And here you see Solidity code. And for a Java developer, it's a little bit like a class, right? So here we have the Solidity version defined that needs to run in the distributed ledger to execute the code. Then we have the real contract. You can think about it as a class. A class that is a singleton, because in the distributed ledger, there's exactly one instance of that contract. And if you define variables in that contract, and whoever changed it, right, there's just one instance, change the value of the variables. And you have those state variables. You can define events to call other smart contracts, things like that. Yeah, you have a constructor, and you have some functions. More or less what we know from Java, right? You have booleans, you have a lot of different integers, because as we've seen, you pay for this operations like a shift and something like that. And that is why you have that much integers, because when you use the lowest integer that makes sense for your use case, you will pay less money. Fixed point numbers are still kind of in development. The address is a special data type that defines the address of a user or the address of another smart contract that you want to call. Byte arrays, enums, you have arrays, maps, structs, if, else, while, for, whatever. Everything we know. You can even do try catch and so on. So once you've written a smart contract, the next thing is you need to compile it. Let's assume we have this smart contract. That's quite easy. That has one function. We do not have any variables, so we do not store anything in this smart contract. We just have a function, and when you call it, it returns hello world. And to compile that one, there's a compiler, the Solidity compiler, that's called solc. You can just download it under soliditylang.org, where you find a very good language documentation for Solidity 2 that for me really helped me to understand what's all that about. The compiler is quite easy. You just say solc, okay, I want to have a binary output. This is the output folder. This is the input contract that I want to compile. Next to having binary output, what Solidity and the compiler is doing, and that is quite nice, you can get an ABI output. And you can think about the ABI like an API that you maybe know from Java. This is in JSON, a definition of all the public access points, like the functions or the constructor of the contract, with all the information like what parameters do I have, what return variables do I have, and so on. And that can help you, for example, to create dynamic code so that you can easily, even from Java or JavaScript, can call such smart contract. If you do not want to install solc on your machine, but have Docker installed, you can even play with it by using a Docker container that has the compiler installed on it, and by just using one command, you can create your own compiled smart contract. There's a Maven plugin for it, and that is great because that even adds, if you want, a Maven wrapper around the smart contract based on this ABI. So it creates a Java class that has the same methods as the smart contract had. And you just need to call the Java class, and then the smart contract is called on the public ledger. To deploy it, you need an API. There are different ones. All of them are open source. For Hedera, for example, that's the Hedera Hashgraph SDK that you can use. There are one for Java, one for JavaScript, Rust, C, C++, whatever. And once you have it, I don't show the code. I will show an example at the end. You can just upload your contract. You shouldn't do it to the productive Hedera network first, because then you need to pay. As already said, we have this testnet, and on this testnet you get like 10,000 HBAR, that is like what you need for gas, each day to just rightly deploy and execute smart contracts. If you're interested in it, you can go to portal.hedera.com/register or just scan this URL, and then you can create an account for our testnet. And then, yeah, you can just execute smart contracts on your system. So I have 2 minutes left. I have one last topic. One thing we haven't talked about it are tokens, right? And that's, everybody talks about NFTs, right? And so we have 1 minute left, and I haven't talked about NFTs. What's wrong with me? I mean, that's the high topic, right? And when looking behind the curtain, in a minute you will see that it's nothing. So what is it? When talking about tokens, we have so-called fungible tokens and NFTs, non-fungible tokens. A fungible token is, for example, a Bitcoin, which means like whatever token of that crypto token type you have is worth the same as any other one of that crypto token type, which means it's interchangeable, right? So maybe the price in general for the tokens goes up and down, but at the end, all of the tokens have the same price. And when talking about NFTs, it's more again like Pokemons or like the Axes we have seen, right? So when you buy a Pokemon card, it's just paper with ink on it, but it can be, I don't know, worth nothing or 100,000 euros. And that's what an NFT is, right? You have the same kind of token, but the price is different. And an NFT is always unique. I mean, even if you say like we have thousands of this type, we have 1,000 super dragon X's, each of them is unique. So how to do that in such a system? That's quite easy, it's a smart contract. So there's the Ethereum, I don't know what ERC stands for, Ethereum Research Contract, something like that, which is more like a JAP in Java, like so a kind of standardization. And the ERC20 is just defining how a smart contract need to look when the smart contract is a token. So if you create a smart contract that has those methods, so you have a total supply, you can get a balance of for a given address, and you can transfer an amount to a given address, and you can give one address allowance for another address, and you can approve the amount for an address, and you can transfer something from one address to another address, and you implement that in any way you want, then you have a token. For an NFT, it's the same. Again, we have a standardization, and again, we just have some methods. And what you need to do is if you want to create your own, I don't know, Java coin, you need to implement that in a smart contract, deploy it into any distributed ledger, and boom, you have your Java coin. If it's, I don't know, if it's good to do that, and if you will get a lot of money with that, I don't know, I assume not. But that is how you can do it. And if you have a good marketing that tells the world that this is the hot new shit, even if it's just some random pictures of apes, where just the URL is stored in the tokens, yeah, then it's just that. But it's really not more than having a smart contract implemented. And to get all the standards, there are already libraries. So the biggest one is Open Zeppelin. That's how it's called. That's a company that provides all those contracts for all those standards. Like when you want to create a token or when you want to create an NFT, you can just use them, and then you just need to add an implementation for it. At JavaLand, this year I did exactly that. I did a workshop there that was like how to create the Java coin, and that's open source at GitHub, and that does exactly what we see now, right? So that implements tokens. It's a Spring Boot application with a small template front end where you can buy tokens, where you can sell tokens to other people, and so on. It contains the smart contracts. It has the Maven plugin to compile the smart contracts, and it has functionalities to automatically upload it to the Hedera network. Yeah, that's it. That is, yeah, the technology behind all that stuff. Are there any questions? So the question is, how can I get gas? So with gas, the point is, gas for me was quite cryptical too at the beginning. And how it is done, and it's the same in Ethereum or in Hedera, you buy tokens on the blockchain. In Ethereum, you buy Ether. In Hedera, you buy HBAR. And that is then used from your account. So when you execute a blockchain, you need to like log in with your account or pass your account to the call. And the H bar or Ether that are linked to that account are then used to pay the gas. And since you always have, I mean, you cannot do it by using, for example, dollars or euros, because you cannot pay less than 1 cent. And with H bar or Ether, you can pay like 0.0001 H bar, for example, which is way less than a cent, but that's why you need to have H bar, for example, on your account to pay the gas. Yeah. Yeah, I know. It was super hard for me at the beginning to understand that. Yeah. Yeah, I haven't invited that. Yeah, I had problems with that to understand it. Especially, I mean, you have, let's say you have euros, and you change that to the token of the distributed ledger, and then what you pay is called gas, right? So you have like 3 different currencies, and that makes it super hard to understand. The benefit is that gas is like a standard, independent if you are on Ethereum or Hedera, it's called gas. Yeah, but yeah, it's not easy to understand. I'm with you, yeah. Any other questions? Yeah. So the question was, the Hedera network has over 12 billion transactions. How is it possible to do that much traffic? No. Ah, okay. Yeah, so, I mean, a lot of the members in the foundation using it. I've shown that one from ServiceNow, right, the help desk thing. Then I showed the game development. Then I showed this logistic company that does the ethics stuff. There are other use cases. LG, for example, using it, they have a new kind of TVs where when you show pictures on it, it don't look like a TV, it looks like a real old illustration. And you can buy NFT illustrations for those TVs. No camera here, I'm not recorded, right? So I have no idea about that, but that's another use case. That is what LG is currently doing. As said, we're in a gold rush when talking about that. There's a lot of applications on Hedera, on Ethereum, on others, where I would say I don't get it, why people creating such applications and doing it. That's why I only showed applications that from my point of view make sense, right? Like having this ServiceNow thing. Or if you want, for example, as I mentioned it, there are now first companies that use it for buying houses or buying large areas and then split it up between several people and doing that on smart contracts. And I've seen even Mattel now has NFTs for Barbie and for, what are the name of the cars? Micro Machines. Yeah. You can now buy NFTs for special editions for the cars. And I think you can then change it later to get the real cars. I don't know. That's another one I don't get. But yeah, there's a lot of, I would say, a lot of companies currently play with it and try to learn how to use it and what makes sense and what makes no sense. I would say whenever you have 2 companies and you need to define an API somehow in the middle and you have a problem with trust, that's perfect. Yeah. Behind you was earlier, yeah. So the question was, why do they use the EVM instead of? Ah, because, so, okay, the question was, so for example, at Hedera, they use the same EVM, but they are faster, right? That was the question. How does it come? So at Ethereum, and that's a benefit. So the EVM and how the EVM is working is standardized. So for Bitcoin, there's just one client, github.com/Bitcoin. For Ethereum, there are a handful of clients. There's one written in Java, there's one written in Go, I don't know, one written in Ruby, and you can use whatever client you want of that and be part of the network. At Hedera, we only have one of them, which is the Java one, and we use the same EVM that the Java clients in Ethereum are using when you have an Ethereum Java client running. The big difference is that at Hedera, we define the minimum like CPU, like RAM, like internet connectivity of the clients. So the calculation and all the stuff can happen way faster than it's done in the Ethereum network. And there was another, yeah. Yeah. Yeah, sure. And that is not how it will stay at Hedera. So even today, what you can do is you can run a so-called mirror node. So you can just download a mirror node container from Hedera and execute it. And all the transaction then will mirrored to your machine and you can check it. You can check that everything is valid, but you are not part of creating consensus. That is currently the state. And the plan is to open it wider, right? So currently we have, I don't know, like 30 different people in or companies in the foundation. That should go up to 50, I think. And then the next step will be to even open it more than it is today. But we do it like step by step for not becoming slow and to keep up the speed and the sustainability. That's the idea. Yeah. There's another. Is that a question or? Yeah. 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 Hmm? Yeah. So if for example a node that is maintained and running by Google is creating the consensus based on your smart contract that you are executing. Then the gas that is paid is splitted somehow between the foundation and Google. I don't know if there's even a third party. I think even people can get something, but I'm not deep into that. I know at least those two parties get it. I think when you have HBAR and you can define where if your HBAR should be on the ServiceNow node, on the IBM node, and on the AG node, and based on that you can even get something with that. But this is quite new, and this is more like the management is doing. I'm not into that. Yeah, 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 yeah. Yeah, sure. This is. I totally understand the point. I mean, with Bitcoin you can do mining, right? Because you find the magic number for the next transaction, and with Ethereum you can do the same. Here you cannot do it at the moment. That's totally right, because you cannot run a node. I mean, you need to become part of the foundation and have a very good machine in your cellar to do it. But normally you cannot become part of the Hedera Foundation. And based on that, you cannot use that to earn money. But from my point of view, so the idea is to have a network that can be used by enterprise to use the technology and to have the benefit of the trust. This is not like for individuals to create money or things like that. Yeah, I would say so. I'm working in the lower parts. I'm doing a lot of threading and things like that. So that's a good question. I want to have an answer when I do the session the next time. Actually, I can just say I assume. That's it. Yeah. Yeah. When you what? When you can use a bank. Oh yeah, it's not about money. I mean, so I had an interesting discussion with a company some time ago that creates small parts for cars. Okay, and they create parts that are inside of the motor for a specific car, and they told me that they have a problem because the car manufacturer, and that's a big one, a word. I mean, there are like 20 of them, right? So it's one of those. The QA department of that company needs to earn their own money. So how can a QA department earn money? They can only earn money by finding problems at the QA and getting money back from companies that create parts for the car. And that ended in a big problem where the company that creates the car parts for the car was afraid that even that they prove everything and prove like every part and have a certificate for every part, the company says, okay, one of our cars exploded and it was because of your small part. And that company, for example, wants to store the certificates or the hashes at the end of the certificates into a blockchain, for example, in Hedera, because then nobody can change it, right? And even if then a car explodes and the car manufacturer says, oh, that was because of your small part, they can say, hey, look, here are the certificate that everything is right. We together decided to store it in this distributed ledger. And that's hard to do with a bank, right? That's why I say it's not about money. It's about things like that. That's when I said whenever you have two companies or persons or whatever that do not really trust each other, then it makes sense to use something like that. Yeah. Otherwise, you can use a database, sure. Yeah. Give me a second. How much? What's the time? Oh, sorry. Okay. So you are the next? There's no one next, but you want to leave. Okay, one last question. Yeah, yeah. We have exactly the same applications. Yeah, you can have a look at each address, have a look at each transaction, and it's the same if you know you have the same kind of addresses, and if you know like that technical address belongs to that real person, you can do all what you can do in Ethereum. So if somebody wants some stickers and shirts from Hedera, they send it to me. If you want some, you can just come to the front.